Good evening, Christian. Thank you for your question. Let me restate your problem and answer your question. You have a support and you have a sphere. It's an equilibrium problem. The sphere is on the support. You have this mass, the mass of the sphere, which is given to be 2.5 kilograms. Question number 1, which I believe you know how to answer. They want you to write the characteristics of the weight. So I assume you know they are line of action, direction, magnitude, and point of application. I assume that you know that the magnitude is W equals M times G, and you have M. So we've done with question 1. Now question 2 was not clear at all to you, and the answer that you have in your book doesn't make sense at all, so you can just ignore it or delete it from your book. Now the question is, you have to explain why the weight is the force exerted by the sphere on the support. You all know that the weight is the force exerted by gravity. In other words, by Earth on the sphere. So how is it exerted by the sphere on the support? You can follow two strategies, or you can think your problem into two parts. Part 1, you have to think about equilibrium, and then the two forces on your sphere are the weight and the normal. This is the equilibrium condition, W equals minus N. Now, the second part of your answer would be, regarding action-reaction forces, you have the force exerted by the sphere on the support that you will call F1 on 2, force exerted by support on the sphere, which is F2 on 1, and the action-reaction law, Newton's third law, states that F1 on 2 is equal to minus F2 on 1. Now let's try to make sense out of the forces. Force exerted by support on the sphere is nothing but, the normal, the reaction of the support. So instead of writing minus F2 on 1, you can write minus normal. And then, going back to your first theorem, since you have minus normal equal to the weight, by identification you can tell that this force is indeed equal to the weight, which means the weight is equal to F1 and 2, which is force exerted by sphere on the support. And I believe we just answered the questions stated by this problem. Let me know if it's clear to you.